This conference will now be recorded.
Hello, my name is Viv Marks, and today we will be discussing how to develop curriculum for students in higher education. I am concerned with students in science programs, including but not limited to agriculture, biology, chemistry, ecology, genetics, or zoology. I am currently employed at a two-year community college in Pennsylvania, so this presentation will be for other two-year science programs in PA. First, I want to discuss the development process of curriculum, followed by who is concerned with the process. We will discuss best practices for curriculum development and end with how two-year universities should work on transferability to four-year universities. Looking generally at how to build curriculum, we have four steps to consider. First is to gather information. Who is learning the information? What do they need to learn? What do they already know? Once an audience is established, we can move on to making objectives and goals for the students to reach. Then we can begin to add content for the course using best practices that we will discuss later in the lecture. Finally, we have a group of evaluators to assure that the material is concise and relevant. To develop a curriculum, sometimes it's best to start at the end. Backwards design is making the goals and outcomes for a class before creating the curriculum. By knowing where you want the students to end, the development of a curriculum is then driven by these goals. One way this process is hesitantly easier for the sciences is that we can create hands-on activities that collaborate what students learn in the course and the types of experiments they can practice. Laboratory components teach valuable problem-solving and critical thinking skills, in addition to teamwork building and individual confidence. The National Science Teachers Association also say that successful laboratory components are beneficial to those going into science instruction, as their experiences help to build their own coursework. When developing a curriculum for the sciences, one must consider the laboratory component and how it ties into the lessons, goals, and outcomes of the program. Using backwards design, beginning with the lab assignments, can help guide the rest of the course. When making changes or introducing a curriculum, of course, it must be scrutinized for clarity and bias. At the community college where I work, to have a curriculum be approved, it must go through the following checks. Beginning with the faculty organization, instructors of the sciences, the different heads of the science departments, and our head of the laboratory decide to make a change. It is then brought to the Academic Affairs Committee, which includes students, faculty, and administration. Next, the Dean of Sciences approves and sends it to our Vice President of Academic Affairs. It finally reaches the big man on campus, our president, and the Board of Trustees. All over the spectrum of the college, there are voices assuring the changes being made and evaluated are beneficial to the students and instructors. One of the best practices to designing a science curriculum is the laboratory component. Labs are choreographed experiences that allow students to interact directly with natural phenomena. It also builds observation and data collection skills engaged in scientific reasoning. Labs must be an integral part of the curriculum and should relate to the lecture. Brown and Peterson recently wrote that lab components for students in the healthcare field are crucial and best if hands-on. They claim there is no real good alternative to physically holding a specimen and manipulating it. Another best practice that should be used when designing a curriculum is considering a student's individuality. Not all students are going to learn the same way, so designing a class to incorporate all the different learning styles will assure that all students have the materials to be successful. I would also include culture and diversity in this best practice. Malcolm Knowles' theory of andragogy states that students will use their past experiences in their learning, as well as needing rationale to make connections. Communicating and treating adult students like individuals builds rapport in a classroom and can be used to design curriculum. Finally, when developing curriculum, universal design can be used to format the class. Universal design does not rely on one sense or ability for a user to complete the course. UDL, its abbreviation, provides multiple means of representation, action, and engagement. This practice assures inclusivity, communication, and flexibility on the student's end. This design utilizes multiple resources in different forms, such as audio textbooks, video lessons, and transcribed captions. The best part about UDL is that it can be retrofitted to old curriculums to be more inclusive. The learning management system Blackboard uses the program Ally, which automatically converts content to alternative forms, such as electronic braille, audio, or Beeline Reader. Universal design is also a great way for students and instructors to communicate and build rapport. Finally, we get to the topic that made me go into post-secondary administration, transferring from a community college to a four-year institution. When designing a curriculum to have students take 60 credits at one school and 60 at another, sometimes things just don't work out. In the case of the school where I work, we have created articulation agreements with institutions that have our students take certain classes in their program, and they can transfer with certainty to have junior status. In other cases, our students can take up to 90 credits that will transfer to a four-year institution if they are taking the approved classes. In Pennsylvania, there is a wonderful website called PA Track, where students can input the classes they've taken at other Pennsylvanian schools and see what the course equivalencies would be. When designing curriculums to be transferred, it is important to do research on the nearby schools to see what their curriculums are like. At the community college level, it is best to start with thorough introductory classes and general electives. As the students build their skills in a specific major, they will be able to confidently transfer to a four-year institution with the appropriate background. Knowing where a student wants to transfer can help guide instructors and advisors as to what classes are important for them to take. Using myself as an example, I took an introductory biology 1 and 2 and a bunch of general electives. When I transferred, I did not realize that I was behind in the curriculum because I had not yet taken my chemistry 1 and 2. At the time, I was able to take upper level biologies, but had to start at the beginning of the chemistry sequence, which put me a year behind. Creating a curriculum to be transferred saves students money, time, and energy. Having introductory classes built into the curriculum assures that when students transfer, the upper level courses can be completed. Designing curriculum is a school-wide checks and balance that assure that students have the best outcome after college. At all colleges, best practices include laboratory components, individualism, and universal design. The laboratory component is an integral part to the science curriculum and should help design a plan. Additionally, universal design allows students multiple avenues to be successful in a course and create the individualism that students seek as adults. Using these best practices, students in the sciences can seamlessly transfer to four-year institutions to earn their bachelor's degree. Designing universal curriculum allows instructors to be more communicative with students and focused on their teaching. Thank you so much for watching this video on designing curriculum. All images are from Google Creative Commons and also the PA Track website. Thank you so much. We'll see you next time.